Hi friends, in this video lecture I will be helping you how to find eigenvalues and eigenvectors. We have already seen how to find eigenvalues, but in this video we will brush it up once more in a rigorous manner. And so let us go to solve this problem. That is, this is a 3 cross 3 matrix, okay, and we are supposed to find its eigenvalues and eigenvectors mainly. Okay, so let us see. The first step in any problem should be, let ax equals to lambda x, where x is not equal to 0. Okay, so x not equal to 0 is the main condition. After that you solve for your determinant of a minus lambda I, that is equal to 0, and this is nothing but your characteristic equation. So in order to solve this, you have this matrix written in the determinant sign and you subtract lambda from the diagonal values. The moment you subtract it from the diagonal values, you equate it to 0 also, and then what comes into the picture is that you have to use your characteristic polynomial formula to solve the LHS. Okay, you solve the LHS and you obtain your characteristic equation finally. So characteristic equation is lambda cube minus 2 lambda square minus 5 lambda plus 6 equals to 0. Okay, so after that you use any basic school level technique, or you have your calculators, then you can use that and you find the factors. The factors are going to be lambda minus 1, lambda plus 2 and lambda minus 3 equals to 0. Okay, here very important note I would like to make, that equation number 2 over here and this equation number 3, they both are nothing but the characteristic equation itself, but the first one is in the polynomial form, okay, and the second one is in the factor form. So both of them are important to us. One helps us to understand it in algebraic manner, other one is faster, it helps to solve the problems. Okay, so just see how which both the formats you should be comfortable to derive. Okay, so I'll just label them with some red star over here. Okay, now coming back over here, lambda is 1, 3 minus 2, and so these are our eigenvalues. Having done that, we observe over here that they are distinct eigenvalues. Okay, so remember that we are having distinct eigenvalues over here. Now let us go to find eigenvector. Now eigenvectors, all of the eigenvectors are going to be in this format: x1, x2 and x3. This is the general eigenvector that we will be calling it upon. Okay, now for eigenvalue lambda 1 equal to 1, we will have a particular eigenvector, say x1. Okay, so let us see how to find that. So you plug up in this equation ax equals to lambda 1x, x not equal to 0, and you have this. When you simplify it, take it on the other side, and a minus lambda 1x is equals to 0. And yeah, from the matrix you have to, from the matrix of each of the diagonal values, you subtract the eigenvalue 1. Okay, and you will obtain the following matrix. Now this is your linear system that you are interested in solving. So you are allowed to use only row transformation. Using these two row transformation, I am going to reduce it into row echelon form, and so finally I have my row echelon form available by doing the following row transformation. So now further, what I observe here is that the rank of a minus lambda 1 I is nothing but 2. Okay, so that is the rank of the matrix. And further, when I simplify for geometric multiplicity, I obtain that it is lambda 1 is 1, because n is 3 and r is 2, so n minus r is 1. Now further, you simplify this system, you obtain these two equations, and from the second equation you will obtain x2 is equals to x3, and from the first equation, when you plug up these values, okay, you will obtain x1 is equals to minus of x2. Now in order to find eigenvector x1, you write x1, x2, x3 over here. What are the relations that you have derived? that's what you are supposed to write then. So x1 is nothing but minus x2. x2 is a free variable because geometric multiplicity indicates the number of free variables. So I am choosing x2 as a free variable. x3 I am writing it as x2. So that's what over here. Now you pull x2 outside, okay, and leave the scalars in the matrix. You obtain minus 1, 1 and 1. This vector that you see is the basis vector for eigenvalue 1. Okay, and so what you obtain over here is this vector, and this is your eigenvector. But this x2 is something putting trouble over here, so I'll put x2 equal to 1. So x1 is equal to minus 1, 1, 1. You are free to choose any value of x2 apart from 1. Okay, you can take 2, 3, 4, minus 10, minus 12, any other, but not 0. Okay, remember that, because x is a non-zero vector. Okay, so any other answer will be just a multiple of this vector. Okay, now let us go to find for lambda 2 equal to 3. Similar procedure goes. Okay, from the diagonal values of the matrix you subtract lambda 2, that is 3, and you get this system of the equation. Perform row transformation and reduce it to the row echelon form. This is the row echelon form. You calculate the geometric multiplicity. You can also avoid if you do not want to calculate. You can solve the system of the linear equation, obtain the relation x2 equals to x3 from the second equation, and from the first equation when you plug up these values over there, you get x1 equals to x2. Okay, now for finding the eigenvector x1, x2, x3, you plug it up the relations that you have obtained, and again here you see that geometric multiplicity is 1, so that indicates the number of free variables. So one variable is free, so I am taking x2 as a free variable, and when I pull x2 outside the matrix I obtain 1, 1, 1, which is when I put x2 equals to 1, I will have my eigenvector capital X2 equals to 1, 1, 1. Okay, similarly for lambda 3 equal to minus 2, you subtract it from the diagonal values of the matrix and solve the linear system using the row transformations and obtain the geometric multiplicity. Again you observe that there is one free variable. Okay, and you solve the system over here. X3 is equals to minus 14x2 and x1 is equals to 11x2. That is the relationships that I am getting over here. Now when x3 you are solving here, x1, x2 and x3, so 11 x2, that's the relationship I got for x1. x2 is the free variable over here. x3 is minus 14x2. So when I take x2 outside, I am left out with the scalars 11, 1 and minus 14 in the matrix. So I plug up x2 equal to 1 and I obtain my capital X3 eigenvector as 11, 1 and minus 14. Okay, now remember that you can choose any other values for x2. Okay, you can not choose 0, but remember x2 if you take as minus 1, it will be just the minus 1, minus 11, minus 1 and 14 over here, nothing else. It will be just the multiple of these vector. Okay. Now, so finally what you obtain is the eigenvectors corresponding to 3 eigenvalues 1, 3 and minus 2. So these are the 3 distinct eigenvectors corresponding to these 3 distinct eigenvalues. Okay, now further in the same manner try to solve these 3 problems. They are over here, these are 3 cross 3 and this is a 2 cross 2 matrix. Also try to find their algebraic and geometric multiplicity, which I have already explained you along with the procedure of these eigenvectors and in my previous video lectures. So till then, thank you.